Hello YouTube, and today we are back at Linux from scratch. I've been procrastinating on this, and also it takes a long time to sit down for a few hours and actually just go through and do the video. So at last time we had compiled libxcrypt, and I was took about 2 hours to get to this point. So what we're going to do this time is I'm not going to read everything all out because it just takes too long, and most of the bits and pieces are pretty much repeats of stuff that you can read yourself essentially. So without further ado, we're going to basically, so what we have to do first is read the general compilation instructions because I've probably forgotten them. Now they're pretty simple. Let's just go through them again. And in the general compilation instructions, this is the important bit. I always kind of forget how this works. We're in a cheroot, so this will be LFS, but this will be his sources. And if we look here, that's sources libxcrypt. So you change to the mount LFS sources directory. For each package, use a tar program, extract the package to be built. In chapter 5 or 6, ensure that you're the LFS user when extracting the package. Well, we're not in chapter 5 or 6, so it's not relevant. Do not use any method except for tar, so we always use tar. Notably, using the copy R command, copy the source code tree somewhere else can destroy timestamps in the source tree, cause the build to fail. Okay. Change the directory created when the package was extracted. Follow the instructions for building the package. Change back to sources directory when the build is complete. Delete the extracted source directory. So we need to exit. So we need to go to, so the first thing we need to do, we need to cd out rm -rf libxcrypt. I think that's it. And then it's tar. What is it? And then it'll be shadow, blah, blah. So what we do now is we cd into this and we go to the install instructions. And I'm going to go through this a little bit quicker. So this is Shadow package. The Shadow package contains programs for handling passwords in a secure way. Okay. There's some warnings about Linux PAM. I'm going to skip those because I've not even seen it. We're not using it. So we're going to go past that. It says disable the installation of groups program in its manual pages as core utility provides a better version. Okay. Also prevent the installation of the manual pages that were already installed. We already installed the manual pages, so we run this. That's all we have to do. Instead of using the default crypt method, use the much more secure yescrypt method for password encryption, which also allows passwords longer than 8 characters. It is also necessary to change the obsolete var spool mail location for user mailboxes that Shadow uses by default to the var mail location used currently, and remove bin and sbin from the pass as they are simply symlinks to the counterparts in /USR. Okay. Right, so there's a warning about not adding these paths to the bash RC. And we're going to copy that. And we're just going to run that. So this is just changing some paths. Somewhere. So prepare Shadow for compilation. Okay. So it makes a password file and then it does the configure. Meaning new configuration options. Yeah, so basically you create a file and then it needs to know where that file is. Okay. Shell expands with 2 switches with bcrypt and with yescrypt. They allow Shadow to use the bcrypt and yescrypt algorithms implemented by libxcrypt for hashing passwords. These algorithms are more secure, in particular, much more resistant to GPU-based attacks than traditional SHA algorithms. Okay. Longest permissible username is 32 characters. Make the maximum length of a group group name the same. So with max group length, okay. With libxbsd, do not use libxbsd. Do not use the read password function from libxbsd, which is not in LFS. Use the internal copy instead. Okay, so we run this, so we understand what it does. Right, that's configured, and we just do make, and I'm going to have a sip of coffee. Oh, that was quick. I got myself a nice coffee before I started this because I knew this was going to be a long recording session. Next, so we need to install the package. It's not just type it in and save ourselves some time and just copy and paste. So that's just basically saying where it's looks like where it's going to install, and I think install some man pages. That seems to work. Now we need to configure it. Okay. Right, so configuring Shadow. This package contains utilities to add, modify, and delete users and groups, set and change their passwords, and perform other administrative tasks. For a full explanation of what password shadowing means, see the docs how-to file within the unpacked source tree. If you use Shadow support, keep in mind that programs which need to verify passwords, display managers, FTP programs, POP3 daemons, etc., must be Shadow compliant. That is, they must be able to work with Shadow passwords. Okay. To enable the Shadow passwords, run the following command: pwconv. So, and grpconv. So to enable Shadow group passwords, run this. Right, Shadow's default configuration for the user add utility needs some explanation. First, the default action for user add utility is to create the user and a group with the same name as the user. By default, the user ID and the group ID numbers begin at 1000. So if you typically, if I do ID, my group ID is 1000 and my UID is 1000. So that's what that's talking about. So I'm the only user on this system. It's create the first user and it starts at 1000. Okay, that makes sense. This means if you don't pass extra parameters to user add, each user will be a member of a unique group on the system. If this behavior is undesirable, you'll need to pass either the -G or N dash capital N parameter to user add, or change the settings of the user group enab in the etc login defs. See user add for more information. Second, to change its default parameters, the file must be created and tailored to suit your particular needs. I don't care about this. This is the problem with this book. It goes into far too much detail. Well, we're just going to use that, whatever that is. Right, so that just basically says, it says 999. The next one's going to be 1000. Well, isn't that default? First, no, also, if you don't have a group with an ID equal to this number, then the first time you use it without the G parameter, an error message will be generated user add unknown, even though the account was correct. That's why we create the group users with the group ID in section 7.6. Okay, create. Right, okay. We'll just run it and. Oh, I'm in the wrong. Helps be in the right terminal. Right, create mail spool equals yes. Does that? What does that do then? I'll do etc default. Right. Okay. So it's made it. So I can't use it. Add. Do I need this? Well, do I want to do that or not? This is what's frustrating. Is I just need to get a working system, and then these peculiarities of maximum configuration. You can go into that like as an aside. I think we'll just leave it like that. Just go back to CD sources. Oh, I need to make a root password before I leave this section. All right. So I now have a root password. Good. Right, now we're compiling GCC again. I'm not explaining what GCC is for the 50th time because I think you have to compile it two other times. So we need to RMF Shadow first, and then we need to tar xf GCC. Right, if building, change the default directory from 64 lib. Yeah, so we are building. So basically, if it says if we're building on the x86 system, which we are, change the default name directory 64-bit libraries to lib. Okay. Oh yes, because we're not in. Yep, in CD, and this is pretty much the same as before. So you make a build directory. We need to make a build directory. Let's do CD build. And we'll do a configure. I'm not going through all of these again. Yeah, disable. I think I've been through these with another video. It would have been one of the previous videos, so we're just going to skip this. Right, let's create the make file. Yeah, so let's create the yeah, so oh wait a minute, it does no, this is actually good. I'm complaining about this guy's book. It's pretty in depth and detailed. However, I wish he just glossed over some things that are just I don't think are necessary to know at this point. So the meaning of the new configuration parameters. So LD, this parameter makes the configure script use the LD program installed by the bin utils package built earlier in this chapter rather than use the cross-built version, which would otherwise be used. Okay. Disable fix includes by default during the installation of GCC. Some system headers would be fixed to be used with GCC. This is not necessary for modern Linux system, potentially harmful if a package is reinstalled after installing GCC. This switch prevents GCC from fixing the headers. Okay, that seems reasonable. The switch tells GCC to link to a system-installed copy of the zlib library rather than its own internal copy. I'm not going to get into Pi position independent executables. All you need to know about this is basically there's a security feature where it makes it difficult to an attacker to assume where a program is running in memory. What you will find in the past, in older systems, certain things will be loaded into certain, especially if it's something like a Commodore 64. There was a memory layout, and you could just read it in the manual. Obviously, it wasn't online or whatever. Typically, a Commodore 64 would never go online. So what hackers started doing is there was like, well, if I'm running this guy's running this version of Linux, I know that this program might be running here, and then there's a load of attacks that you could do by that. You can basically just work out where, say, a particular piece of data was in memory, if you knew the size and where it was likely to be on stack. So you could do attacks based on that. That's a pretty bad explanation, but this is all this is. This is something I think most modern operating systems do. So anyway, we now just do make, and this usually takes a while. Should have probably kicked off make before I started waffling about high position independent executables. After this, we have to run the test suite, and this is going to take a while, I think. Right now, that's built, and then right, so let's read this bit where it says important. In this section, the test suite for GCC is considered important, but it takes a long time. Okay, first-time builders are encouraged to run the test suite. The time to run these tests can be reduced significantly by adding JX. So -J4 will be mine, I think. That'd be the value of nproc. The make kcheck command below. where X is the number of CPU cores on your system. Yeah, so I've got 4 on here. I will probably be seeing how long this takes. I think I'll be going with 8 or 16 cores in future, just to give myself, it just takes less time. GCC may need more stack space compile. Right, so this is basically, we need to add a J flag to make it speed up a little bit. That's fine. GCC may need more stack space compiling some extremely complex code patterns as a precaution for the host distros with tight stack limit explicitly set the stack size. Okay, so we're just going to run this. I don't think it will make. Oh, come on. What is my mouse doing? There we go. Right. So this, we remove some test failures from the test suite. Okay, that are known to happen. Okay. Right. So it's capital R, bonker. So we change the test suite to that, and then we just run this, I guess. Oh, now we've made the J flag, and we just let this go. Apparently this takes a while, so I'll make another cup of coffee, I think. That took quite a while. So what we need to do now is we need to check the results. And what we're going to do, it says filter out only summaries, pipe the output for grep a7.a7 sum. That's what we're going to do. And we're just going to do a quick comparison. Hopefully this is all good. Okay. Let's just run it without the grep. It looks like it's... Let's have a look at the results from the Linux from scratch. Ooh. Where's GCC? Is it 827? Yeah. So if we have a look here, so this looks like what we want to look at. If we go to let's have a go. Let's go to the top. This G++ test. We're looking at the right bit here. these seem to be like roughly the same. There seems to be a lot of number of unexpected failures, 11. Number of unexpected failures here. GCC. The number of it's right. So I've got no unexpected failures in this G++ summary. So it looks like, so I actually have less unexpected failures. So these expected failures are, I think they're the same. If we just do a quick compare, 2764, 2764. Number of expected failures, 1465, 1465. If we go down here, number of expected failures, 32. So this seems to be libdis++. These seem to be rough. These seems to match up. I just have less unexpected failures, so that I suppose it's good. So I think they're roughly the same, which isn't too bad. Right, so I think that passed okay. Yeah, unless the test results are vastly different from those at the above URL, it's safe to continue. So I think we're okay. So we're going to do a make install. Hopefully this won't take like an hour and a half or whatever it took. It took like about an hour and a half. Right, so we do the make install, and then we changed the change the owner to tester, and now we're going to change this back, all of these back to root, which is what they should be. Yeah, from tester root to root. That looks like that worked properly. Create a symlink required by the FHS for historical reasons. So that's just a symlink. Let's do that. Many packages use the name CC to compile the C compiler. We've already created a CC as a symlink in GCC path 2. Create its man page as a symlink as well. Okay, let's do that. Add a compacting symlink to enable building programs with the link time optimizer LTO. Okay, let's do that. Not sure exactly what that does. Right. Now this says, now that our final tool chain is in place, it's important to again ensure that compiling and linking will work as expected. Okay. We do this by performing some sanity checks. One day I'll get better at reading this. I seem to stumble over many sentences. So we're just going to copy that. Right, there doesn't seem to be any errors, so we're good. And we do get that output. That's that there by the looks of it. Make sure we're set up to use the correct start files. So that. Well, these are just checks by the looks of it. Yep, they're the same. Verify that the compiler is searching for the correct header files. So again, we do that. And that is the same. Yes, it is. Right, so we verify the new linker is being used with the correct search paths. Okay. GNU lib64, 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 USR, lib64, GNU blah blah blah, local lib, USR lib. Okay, that looks good. Make sure we're using the correct libc. Okay. Yep. So this is just a list of checks by the looks of it. Found LD links, blah blah blah. Yep. Right. Well, let's just delete this. Right. I'm going to stop the video there because it is now dinner time for me and it took far longer than I thought it was going to. So I'm going to stop recording here and I'm going to probably pick this up later on and do a third video where I compile all the other bits and pieces. Hopefully that won't take nearly as long and won't take up my entire evening. And hopefully I'll see you in the next video. So bye-bye.